Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 9, Lesson 3, Solving Quadratic Equations Using Square Roots. After this lesson, you'll be able to solve quadratic equations by taking the square root of both sides. For the Explore and Reason, we have this developer, and they are building 3 square recreation areas, as you can see, the blue, the pink, and the red. And then we have this triangular area in the center. How can we determine the side lengths of the enclosed triangle? Well, if we know these are squares, then we know that this side length will be the same as this side length. So remember, the area of a square is equal to side squared. So I can take the area of the largest section, for instance, and know that it is just the side length squared. Take the square root of both sides, and I will have the length of each side. What relationships do we notice among the areas of the squares? Well, if we take a look at the area of the smallest square and the area of the middle square, if you add those together, the sum of the 2 smaller squares will equal the area of the largest square. So hopefully that makes you think of the Pythagorean theorem. So in that case, we know that this is a right angle. So then we could calculate the length of this side, and we could calculate the length of this side. We could calculate the length of the hypotenuse even. But to find the area of a triangle, remember it's 1/2 the base times the height. So once we have the 2 sides from the small and the middle square areas, we can just divide that by 2, and we'll get the area of this triangle shape. How can the developer adjust this plan so that each recreation area covers less area but still has a similar triangular section in the middle? Well, so that just means we want to shrink the whole plan. We could multiply each of the side lengths by the same scale factor. For instance, we could make it all 1/4 smaller, so multiply each of the scale factors by, so for instance, we could make it 1/4 smaller, so multiply each of the side lengths by 1/4. And it would still have the similar arrangement. How can square roots be used to solve quadratic equations? Well, you might have seen me do this in a previous lesson. Let's review taking the square root and solving roots. If I have x squared equals 49, I know 49 is a perfect square. If I take the square root of both sides, taking the square root of a square will cancel that operation. And we just have to remember that we can square a positive value and we can square a negative value to get the same positive product. So don't forget to have your answers be positive or negative when you take the square root. So the solutions would be 7 and -7. What are the solutions for this equation? Well, again, we're going to just take the square root of both sides. Can we take the square root of a negative number? Well, no, we can't square a number and then get a negative. So there are no real solutions for this because we cannot square a number and get a negative product. Try it number 1. Let's solve the equation by inspection. So again, we're going to take the square root of both sides. If you know your perfect squares, then you know the square root of 169 is 13. Don't forget to do the positive and negative. For B, can we take the square root of a negative number? No, we cannot. There is no real solution. Example 2, what if we have a coefficient in front of our squared term? Well, that's okay. We are just going to use opposite operations, the property of equality, and get rid of the coefficient. So we just have to divide both sides by 7, divide both sides by the coefficient, then we would have x squared equals 16, and then we can take the square root of both sides. X is going to equal, don't forget the positive and negative, square root of 16 is 4. Okay, same with part B, we're going to divide both sides by the coefficient. This is good because we started with a negative constant, but we can't take the square root of a negative, but if we divide it by another negative, we will get a positive. And then we can take the square root of both sides. Don't forget the positive and negative. The square root of 8 is going to be an irrational number. The decimal will continue on and on forever. So we can leave it in radical notation. This will be the most accurate answer, so we do not need to round our decimals. We could also simplify. We could simplify our radical if we wanted to remember that it's the same as the square root of 4 times the square root of 2. So we can do positive or negative 2 times the square root of 2. That would also work. Try it number 2. What are the solutions? So for part A, we're going to divide by the coefficient on both sides. We'll have x squared equals 25. 25 is a perfect square, so x equals the plus or minus 5. For part B, we need to get rid of the coefficient, so we're going to multiply by the reciprocal. Don't forget it is negative, so we're going to multiply both sides by negative 2. That will give us x squared equals positive 72. Take the square root of both sides. X is going to equal positive or negative square root of 72. Can we simplify this? I know 72 is the same as 9 times 8, which is 4 times 2. So there we go. I've got all my squares. And so if I split the radicals, again, this is a review from a previous topic, from previous lessons. I'm going to have the square root of 3 is 9, times the square root of 4 is 2, times the square root of 2. Okay, so multiply 3 times 2. My final answer would be 6 times the square root of 2, positive or negative. It also asks us to state what two integers the solution will be in between. Well, so the square root of 2 is about 1.41. If you multiply that by 6, you're going to get between 8 and 9, or between negative 9 and negative 8. Example 3, now we have another constant involved in our equations. That's okay, we're just going to keep following the property of equality, apply our opposite operations, and solve for x. So first thing we need to do is move the negative 5 to the other side by adding 5 to both sides. So I'm going to add 5 to both sides. 3x squared equals 27. Now we can divide by the coefficient. X squared is going to equal 9. That is a perfect square, so don't forget your positive and negative 3. Try it number 3, same thing. Let's first move the negative 19 over. So I'm going to add 19 to both sides. It's going to be 163. Then I'm going to divide by negative 5. And I can see that I'm going to get a negative number right here. So can I take the square root of a negative number? No, I cannot. There's going to be no real solution for part A. Part B, we're going to subtract 17 from both sides. So then we'll have 3x squared equals 192. Divide both sides by 3. X squared is going to equal 64. That is a perfect square. I like that. Take the square root of both sides. X is going to equal positive or negative 8. Example 4, our application problem. As I'm looking at the picture, I can see I'm probably going to be using the Pythagorean theorem. So hope you remember the formula for the Pythagorean theorem from pre-algebra. Remember, a squared plus b squared equals c squared. Like in our warm-up, the square of each leg of the triangle will equal the square of the hypotenuse, the longest leg of the triangle. A cell phone tower has a guy wire for support as shown. The height of the tower and the distance from the tower to where the guy wire is secured on the ground is the same distance, so that's why they're both labeled x. What is the height of the tower? So we're solving for x. So again, setting up our Pythagorean theorem, side squared, or a squared, plus b squared equals the guy wire, the hypotenuse is 200, so that's what they did. And I know that since they're both the same length, it's just going to be 2x squared equals, and 200 squared is 40,000. And I can divide both sides by 2. Now I'll have x squared equals 20,000. Take the square root of both sides. So x will equal the square root of 20,000. Let's simplify that. So we're going to break it into 2 times 100 times 100 because I know 100 is a perfect square. Square root of 100 is 10. And I have that twice, so I'm going to have 2 10s on the outside I'm multiplying. and then leave your square root of 2. So again, we can split the radical. And don't forget your positive and negative. So the length of each side of that triangle, the height of the tower, is going to be positive 100 times the square root of 2. We can estimate that. So if we do that math, we know it can't be the negative version because we can't have a negative length. So if we just do the calculations, 1.41 times 100, it's going to be approximately 141 feet. Find the distance from the base of the tower to the midpoint of the guide wire. So now we have a different right triangle. We know this side is still x. If it's the midpoint of the guide wire, we're cutting this in half. So then what's that length from the midpoint to the ground? Well, we know it's going to be 100. And we know x is approximately 141, do we not? Okay, so if we're looking at this triangle that's drawn now, the hypotenuse now is 141. So we need to make sure we set up our Pythagorean theorem equation correctly. Side length squared, 100 squared, plus the missing side length squared is going to equal 141 squared. We'll have 10,000 plus z squared equals 19,881. Subtract the 10,000. Z squared is going to equal 9,881. Take the square root of both sides. And z is going to equal approximately 99.4 feet. We made it to the concept summary for solving quadratic equations using square roots. It's very simple. Just remember your property of equality. Make sure you do the opposite operation to both sides. And very important, do not forget the plus or minus when you take the square root. And remember, you cannot take a square root of a negative number, at least in Algebra 1. There is no real solution. If you have any questions, put them in the comments. Make sure to like and subscribe. Come back for lesson 4.